Good afternoon or good morning, everyone, depending on where you are zooming in from. I'm Kaylin. I am the Trade Show and Events Manager at MetalCon. I am here to help co-present and to host today's webinar. Today's webinar is Sealant and Adhesive Technology for metal construction applications, being presented by Dan Garnett with AdFast. We're so excited to have him here with us today, and we're very excited about potentially seeing what he has for us at MetalCon in person a little later on this year. We're very excited to announce that MetalCon has our housing block open. That means that you can book your hotel rooms now. If you were available or around at MetalCon 2023, then you know full well we ran out of hotel rooms very early in the game. So book early, save your money early. The link and the information for the website and how to book is all on the screen right here. We are so excited that MetalCon is coming to Atlanta, Georgia a little later on this year, October 30th through November 1st of 2024. We will be having registration opening up very early this year. I'm not going to give a date, but I will say it's coming in early spring. I'm also very excited to announce that some additional and new information will be coming out, including some additional accreditations available for individuals attending MetalCon this year. We are also very happy to let you know that you can receive credit for today's webinar. You can receive credit through receiving a certificate of attendance where you can self-submit that to multiple different organizations. If you have any questions, any comments, concerns, or issues, please either message myself or Dan in the chat. I'll be monitoring everything and we'll be happy to share any pertinent questions at the time with Dan, or we may hold certain questions until the end. We look forward to having you with us. I'm also very excited to ask you all, where is everyone coming in from today? Who's zooming in from the great state of Massachusetts? Who's zooming in from California? Where are you guys coming in from? Send us a chat right in the box below. We look forward to having you with us today. I'm going to hand it over to Dan. Dan, take it away.
Thank you, Kaylin. It's fantastic to be with you all, and I'm going to go ahead and share my screen. And Kaylin, if you could give me a quick heads up that everything looks good on the screen before dropping off too quickly here.
Promise I will.
Okay, everything coming up okay?
Coming up great.
Okay, fantastic. Thank you so much.
Yep.
So hello, everyone. My name is Dan Garnett. I am a Market Development Director for AdFast Corp. We are a Montreal-based manufacturer of sealants and adhesives and insulating foams. And we also bring to market quite a few of the accessory items and installation type items that are complementary to those types of products. So I'll be glad to connect with you today for the next hour or so. I don't have a hard stop at the end, so if we have some questions and answers, if we would like to have a question and answer session toward the end, I'd be glad to do that. I'd also would be open to connecting with you all individually if you have a specific project that you're currently working on or that's upcoming where you have some questions about the technical nature of some of the applications or the products as it relates to sealants and adhesives or insulating foam. I would be glad to connect with you and or your team. So I like to start off with, I think this is one of the last slides in our presentation. I should just copy it and bring it to the front, but this is my contact information. So feel free to reach me directly should you have any questions. You'll also note here that our technical team at AdFast Technical at adfastcorp.com is a fantastic group of very, very highly skilled professionals in this realm. Together between the 4 or 5 people that are monitoring this box, there's well over 100 years of experience with sealants and adhesives. So feel free to drop us a line there or put them in CC when you're reaching me directly. So I'd like to do a quick video of AdFast to give you an idea of who we are. Make sure. Okay. Some great tunes there behind that video, huh? So it gets us nice and awake and ready to rock and roll for some great content to share with you all today. So the course name here, this is one of several courses that we are bringing to market in terms of educational content. In fact, I'm here in Boston today, or near Boston, where I delivered an architect presentation yesterday, and I'll be delivering another one tomorrow. So we're doing this quite often. Yesterday was our Making Sense of Sealants presentation, but then we also offer a building facade glazing presentation and a compatibility and adhesion considerations presentation that should be be able to provide you all with some good information for your projects as well. So let us know if you have any interest in those. For this presentation, the sealant and adhesive technology for metal construction applications specifically, I'd like to go ahead and review with you some of the content of the presentation and some of the objectives we'd like to accomplish today. So we'll take just a few moments to review who ADFAST is. Again, I mentioned that we're a Canadian-based manufacturer of sealants and adhesives. We actually bring products to market all across North America, so I'll have a nice diagram for you there. We will discuss the moisture cure versus solvent-based technologies for the various different types of sealants. We're going to take a look at those that are drying by evaporation and those that are curing by way of drawing in moisture from the ambient surroundings. We will address some of the differences between the sealant technologies. There are silicones. There's a couple different types of silicones, in fact, and polyurethanes and hybrids and thermoplastics you'll also see in the market. We will pull the curtain back a little bit, so to speak, on some of the ASTM testing that's performed to ensure that we are bringing you all or providing you all just as our manufacturer peers are doing as well, such as Dow and 3M and Sika and Tremco, with all the technical data that you would need to do some comparisons of the different types of performance criteria to help identify and determine, and ultimately, if you're specifying, to actually specify the correct product for the application, using lots of different considerations along the way, such as adhesion capabilities, the movement capability of the sealant, the elastomeric properties, the compatibility of the sealant with other chemicals in the application, or also, even more importantly, with the substrates that the adhesive sealants will be adhering to. And we'll take a look at some things like staining and pitting or bubbling of seals, joint seals. So lots to cover here today for that, but the ASTM standards are a set of testing for these sort of applications that, while we can't perfectly mimic in the laboratory, real life conditions, it's different in Boston than it is in Phoenix, and certainly for Seattle versus Miami. Lots of different types of environments, and it changes throughout the year. So we will do our best in conforming to ASTM standards, and just as our competitors are as well, to make sure you have that information available. There are certain sealants that would be ideal for metal roofing applications and also for architectural metal paneling. So if you're working with these types of projects, we'll address that as well. For the building envelope, there are a few slides that I'll have for joint design and the very important application procedures, especially if it's a structural system, and then cleaning method is part of that installation procedure that's very, very critical to the success of the sealant. Backing and tooling, also a very important component. And then we can get into understanding some of the material compatibility that I referenced, the different types of packaging that will be available for various different types of sealant technologies. And as you're considering which technology to use, it's also important to understand the environmental footprint that the use of those products, not just at the time of installation, but also the sustainability factors for the project long term. And then we'll review a little bit more about ADFAST toward the end, provide some important reference links, and discuss some of the other types of items that we're bringing to market. So lots to cover today. So we are, again, a manufacturer of sealants, adhesives, and insulating foams, and quite a few other different types of complementary items. We've been at this for over 40 years, and we're Montreal-based. However, we have stocking locations across North America, and we're really excited to be bringing later this year another stocking location in Mexico. So this will be an addition for us because we've starting to gain a lot of business there in Mexico as well. Not just in the commercial and residential construction market, but also in the industrial production and manufacturing space as well. There's a lot of products that are manufactured or produced upstream from the projects that you all are working on. Think of mattresses or packaging. The products that you need for your project are coming in. So we develop adhesives for these types of products as well. What we're going to focus on today is going to be more in the realm of sealants and adhesives. So there are those that are 100% silicone. So this is a neutral cure silicone in the DWS, which stands for doors, windows, and siding. And this is a class 50 through ASTM C719, which is going to offer the 50% elongation and 50% compression for your joint applications. And then we have a low modulus as well that is going to be able to offer up to 100% elongation, whereas we can't quite get to 50% compression, right? I'm sorry, 100% compression. So this is why it's 100/50. And then we get into our acetoxy series. So although these are all silicone based, the first two here are neutral cure, as well as the last two here. But then your acetoxy is designed more for your interior applications. So there is some acetic content there. So we've got to be mindful of using this, whether it's, if it's an untreated or unfinished, unpainted metal applications. The acetic content is actually helpful because we are we're working to reduce or mitigate the mold and mildew for these interior applications. When we're exterior, there's a lot of moisture, but there's also a lot of airflow. When we're working interior, there's also a lot of moisture in areas like kitchens and bathrooms, but not necessarily the same type of airflow. So it's important that we have that additional mildew resistance there. And then our structural, this is more for the structural curtain wall systems, but it can also be used in some other structural adhesive applications. And then the production series, this goes into a lot of the doors and windows that you see being installed for your projects. So there's lots of different types of technologies, and in fact there's others that are as well, like crack fillers, acrylic latex crack fillers for interior interior finish applications. There are gutter sealants. There are polyurethanes and hybrids as well. So as you get into some of these others, so you're looking at the paintable version. So this is a hybrid MS polymer sealant that is going to offer class 50 movement capability, but it's going to be paintable. So we're seeing this a lot in residential construction. So if you're working, you're aligning with some paneling for the exterior of some of your metal applications. If you have a butt joint for metal to siding, for example, like James Hardie, LP Smart Side, Ceraclad, something like this, you're going to potentially want to paint that on down the road. So you might want to move with a paintable product, such as the 1940 hybrid series. And then your 1090 and 1070 series will be more for interior applications. We do have an e-commerce platform where we have a lot of technical data sheets available, safety data sheets, and you can take a look at the various different options. For example, I think that teaser video that I showed at the beginning indicated that we have over 270 colors of sealant available. We're now over 400. So you can choose there's different types of tools we'll take a look at toward the end of the presentation, if everybody still has some time, on how you can use a drop down to actually select the type of manufacturer. If it's an ACM panel, for example, if it's a Rainabond or a Lucabond or a Allure or something like this, you're able to actually select the manufacturer and the color, and then it'll kick out the perfect color match in terms of the sealant that you can use for that application. So how do we choose the correct product? There's so many different types of technologies available. You know, this picture probably looks just like your home improvement store just down the road from you. It certainly does look like the shelving at the one that's near my home. And you know, this can be pretty daunting, can be pretty challenging, especially for people who aren't doing this very often. We get to this aisle in the store and we start thinking, okay, I've got to read a lot of fine print here. Maybe, you know, at least these days we can pick up our phone and actually do a little bit of research. But there's so many different types of technologies that are available. And, you know, when you're at the home improvement store, this aisle might actually smell a little bit vinegary. And this is because a lot of the, you know, not neutral cure, but a lot of the silicones are going to be acetoxy silicones, which would be used for kitchens and baths. So if you're at a home improvement store, that's probably what your project entails. So that's something to keep in mind, as well as that we have so many different types of products that are on the market. What are the important factors for making the best determination of the product that needs to be on that project? We first should understand if it needs to be painted or not. If it needs to be painted, we would certainly recommend, especially for an exterior application, that we would go with a 1940 hybrid series. 1940 is the AdFast number, but of course, if there's a hybrid from some of the other manufacturers, this would be recommended as well. And then we would need to determine if the substrates would be sealed or adhered. Now, the term adhesive sealants provides a range. There are many sealants that are going to finish off a little bit more hard. They're designed to be a little bit more on the adhesive side. And then there are those that are going to be a little bit more soft and flexible and rubbery, to where they're going to, we're looking to maximize the movement capability, the elastomeric properties of that product. And it could be, for example, if it's a control joint for masons, but you know, we're seeing in metal panel systems, depending on the size, and we're seeing much larger, you know, a much larger breadth of metal panels being used, and there's a lot of movement potentially with some of this aluminum, so the joint size can move quite a bit. So this is where we want to maximize movement capability in addition to adhesion. We'll need to determine the conditions of the application as well. It's super important that we understand the substrates. If there's other chemicals that, you know, could actually be in that particular application as well. And then we'll need to understand the size of the joints. This is going to help us determine if we're able to go with a single component, or if we'll need a two-component product to actually seal that joint. If we're working with one component product sealants on your projects, it's actually probably being installed at the job site level. There are some prefab situations where we're seeing a two-component sealant, adhesive sealant, used in the production manufacturing of some storefronts and some curtain wall systems, where they're actually going to prefabricate the entire system, and then it gets trucked in and then hoisted into place with a crane. So it's not as common to see that. Most of the time we're seeing cartridges and sausages being installed on the actual project, which is going to be a single component sealant. And the compatibility, again, is very, very important. As part of understanding the conditions of the application, we need to make sure there's not going to be staining if we're joining you know, metal applications up to a masonry wall or concrete or stone, some porous type materials. We would have to worry about the sealant sort of leaching in to those substrates, or bleeding in, where we can see some staining take place over time. A little bit more common with certain types of polyurethane in the market, and especially after it's been exposed to UV light over time. So super important to understand that. Let's dive a little bit deeper into the moisture cure versus the solvent-based. So the moisture cure sealants, such as the ones depicted on the left here, are going to actually cure by way of drawing in the moisture. The ambient humidity is being drawn in. So the bead that you're installing today isn't going to shrink in size certainly not right away. If you're using a NeutralCure silicone, it'll never shrink in size. The bead that you install today is the bead you'll have for many, many years. The hybrids are much the same. And then the polyurethanes are curing by the same method, but it's actually going to have some UV susceptibility in terms of the structural integrity of that product. The UV light tends to break down polyurethanes over time. So we certainly wouldn't recommend that for exterior applications. We do bring polyurethane to market, but in fact, we bring a lot of polyurethane to market, but it's more for those production and manufacturing applications that I referenced earlier, where the adhesive is being used in a hidden application, not in something that is going to be affected by UV light. Conversely, the solvent-based adhesive sealants are going to not cure by way of drawing moisture in. In fact, they're actually evaporating. The solvents, and or in some cases, if you're an acrylic, water-based type sealants, we're actually curing by way of drying. And so the bead that you install today is not necessarily the bead that you're going to have 30 days, 60 days, 90 days from now, and certainly not a year from now. So there's a lot of filler of solvent and water in some of these types of products. So we need to make sure that we are using them for the correct applications. When we're doing a moisture cure bead, it's important, and I'll have some slides later on this, that we're actually having some concavity to the bead, that we're pressing into the joint cavity, we're tooling it, we're pressing it in, and there's some concavity to the bead. When we're using a solvent-based material, we want to have it to be more convex, where there's a little bit more of a hill. It's a little bit more rounded of a bead because we know that it's going to shrink down over time. So let's take a look at some of the different types of technology. So the silicones, hybrids, polyurethanes, and thermoplastics that I've referenced. The thermoplastics, one of the challenges is that it's got high VOC content, right? So this is something that when we look at sustainability, we certainly want to try to go with those products that are going to offer much less VOC content. And also those that are going to be curing by way of moisture versus evaporation, that helps a lot as well. The solvent content for polyurethane, there is a little bit, but it's very, very, very low. And then you're seeing in the hybrids and silicones that there's essentially it's 0% solvent. So the UV resistance that I've referenced is super important for the durability of the bead of seal over time. The thermoplastics has low to moderate UV resistance. However, the polyurethanes is probably one of the biggest culprits for joint sealant system failure because it's organic in composition and breaks down quite quickly relative to that of hybrids and certainly to that of NeutralCure silicones. So when we're looking at the life expectancy for exterior sealant applications, we can expect over 25 years. In some cases, we would even say it's might as well call it a 50-year product. It's NeutralCure silicone, it's inorganic in composition, and it won't break down over time like the polyurethanes will and the thermoplastics. So this is why this is fast become, over the last 10 years, the spec for commercial construction. So if you're familiar with the Dow 795 product or Sika 295 or Tremco Spec 2 for AdFast, it would be the R4580 series. So these are the types of products that you're going to have excellent life expectancy and durability over time. The hybrids a little bit less, and polyurethanes are 8 to 15 years, although I think I've got some pictures in this slide presentation to show where there's some breakdown sometimes. If you're, especially here in the northern hemisphere, we get a lot of sunlight on the south side of the building. So the south side of the building typically goes a little bit sooner. We've seen as soon as 2 or 3 years some breakdown take place. Paintability, so all the three on the bottom are paintable, but the NeutralCure silicone is not. So we bring the polyurethanes to market for the hidden adhesive applications in production manufacturing, and also in some construction. You think of hidden adhesive applications there, like a sill plate, for example. A little bit lower of a cost, and you don't have to worry about UV light. The hybrids will be for those applications that will require some paintability. And then, of course, if we can get to the best durability and the best compatibility technology, we'll get to the NeutralCure silicone. There are some hybrids that I should mention that most of them, in fact, in the market are not toolable. And we'll discover a little bit more about tooling as the presentation goes on, but a neutral cure silicone, we definitely want to tool that into place. And with hybrids, generally speaking, we don't want to tool them into place because it can cause a chemical reaction when we're doing this, and it actually causes a chalking effect. If you've ever seen that on a project where it looks like the sealant's starting to fade or discolor a little bit, but in reality, it's actually this chalking that takes place, and you'll start to kind of get white, more and more white on the exterior. The elastic recovery is super important as well, because a neutral cure silicone it's a rubberized silicone sealant. It always wants to go back to its initial shape. So we are able to have excellent performance there for elastic recovery. So that's what's going to help over time as you have your substrates, especially when you're dealing with metal substrates to different types of other substrates that might have a different thermal coefficient, different movement. The hybrids do offer pretty good, and polyurethanes as well, while the polyurethane is still intact, and the thermoplastics offers moderate elastic recovery. So there are all of these on the market. We don't at AdFast bring thermoplastic to market because of the VOC content and because it does break down quite quickly as well. However, it is used in the market. There are some applications where thermoplastic is actually going to offer a little better adhesion initially, but then as it flashes off and you're losing some of the solvent content that helped to get with that initial adhesive bite, you start to lose adhesion over time. And then because it's not able to handle the movement capability, as you see with elastic recovery, it starts to break down more quickly. And then we're going to have joint system failure quite a bit earlier. So this is why we're doing the bulk of our business in residential and commercial construction for both neutral cure silicones, the acetoxy silicones for interiors, and then the hybrids as well for paintability. So as mentioned, when we're doing a bead, if it's going to be a sealant that's going to actually cure by way of drying, by evaporation, we want to, instead of tooling this into place and having this sort of at a 90-degree angle, we'll actually want it to make it a little bit more convex, a little bit more bead-like. And so and by the way, if it's exterior, we don't want to tool it into place either. The reason why is because you're going to lose up to 30 to 50% of the actual volume of that product because there was a lot of filler in the product. So it's drying, but as it's drying, it's causing some of these micro fissures, it's cracking, and then we can actually get some voids, and it's going to allow some moisture to come through. Or if it's intended to help as an air barrier as well, then now we're opening up a lane here for heat loss as well, or heat transfer, I should say. So this is something to keep in mind as well. Now, when we're doing a neutral cure silicone bead or a hybrid bead, you wouldn't necessarily have to worry about this evaporation because it's curing by way of drawing in the moisture. So it would remain, if it's filled to the brim, and for a neutral cure silicone tooled into place, it's going to remain just like that over time. This can help quite a bit. What we're ultimately looking to do is for it not to shrink down to the point where we're losing the structural integrity of the sealant itself because we're losing a lot of the actual content of the bead. Here's an example of a thermoplastic sealant. This is after 8 years, so you'll see full failure here. It didn't last over time. A lot of cracking that took place as it was drying, and as we know, cracking begets more cracking, and it's sort of a snowball effect. It happens once it starts to happen. Now it's going to happen at a more rapid clip over time. So this is really important to keep in mind, is that you might have some good initial adhesion, but as time goes on, as we're starting to break down a little bit with the thermoplastic, it's going to become a lot more challenging to keep the performance here, to keep moisture out of that joint cavity. Those that are cured by moisture, your silicones, hybrids, and polyurethanes, we will first kind of dive into what are the differences between a neutral cure silicone and acetoxy. I mentioned earlier that acetoxy silicones help to provide a little bit extra mildew resistance. This is important for your kitchens and bathrooms. Moisture is in the area, but not as much airflow as we would have outside. So this is very, very helpful. Plus, you don't have as much movement. You have more non-movement type of joints in for your interior applications. Sometimes we refer to them as angle joints. And you're going to be able to seal there. It could be an air barrier. It could just be prevent water from, if it's like my daughters who wash their hands and they're washing everything else in the room when they're doing that, water from getting to the backside of your kitchen sink or your bathroom sinks, etc. That acetic content is there. We've got to be mindful of, untreated, unfinished, unpainted type of metals when we're working with acetic content, because it can be corrosive. If it's been treated or been painted, there's not as many issues, but we need to understand this is more for interior applications. Because it's an acetoxy, not the neutral cure technology, it doesn't have quite the elasticity and therefore, nor the adhesion. So it's not going to handle the movement capability as well either. So this is why the shelf life is actually about 25 years on an acetoxy. Whereas for a neutral cure silicone, it can sit on a shelf for a very, very, very long time. You're, in the right conditions, your elasticity that you're getting up to 100%. Again, with a low modulus neutral cure silicone, this is sometimes used when we're in porous substrates. Masons will use this a little bit more often. So this would be like our 4600 series. Dow has a 790, 791. There's various different types of low modulus sealants that are in the market, but you can get up to 100% elasticity. So if you are working with a 1/4 inch, we'll call it a 1/2 inch joint, in that joint, the substrates move such that, it's maybe the sun was beating on it, it was a dark panel. We'll just call it a black panel, metal panel that's being used for a building facade. The sun's hitting it, and now the sun goes back away, and the sun's dropping, and then that panel, which you probably could have fried an egg on earlier that day, is going to rapidly decrease to the ambient temperature. And so when that happens, you're actually getting some shrinkage of that aluminum taking place, and so the joint cavity will increase in size. And so if we're going from a 1/2 inch to a 3/4 of an inch, that would be 50%, which is pretty common. But if for whatever reason it ended up going up to a full inch wide cavity for that joint system, the low modulus sealants could actually withstand that over time. It can stretch to that much, but always won't want to come back upon itself. And again, if there's compression, it's been cold overnight, everything's been sort of constricted, but now the sun comes up and hits the panel, it warms up, it's expanding, it will actually take up to 50% compression. The neutral cure silicones are not corrosive on almost all materials. It's the most compatible adhesive sealant in the market, is the most compatible technology of sealant in the market. And for these reasons and many others that I'll have for you in this presentation, this has become the go-to for your residential, commercial, and structural, non-structural caulking applications. The vinegary type smell comes from that acetic content that I mentioned earlier. It's there for at the time of installation for your interior projects, kitchens and baths, but then it actually flashes off and it's not there long term. So, but the benefits of having the acetic content as part of the formulation are going to be there a long time. The product, as I mentioned, has limited adhesion on certain types of substrates, but it still offers you excellent UV resistance. However, we're not really recommending this product to be used for exteriors, so we shouldn't have as much worry about the UV resistance. The neutral cure that I mentioned, this is the class 50 movement and capability. This is the class 100/50. So it's offering low odor, terrific adhesion on a variety of substrates. There are some 2-component systems available for neutral cure silicones as well. The 2-component is generally used more in prefab shops where they're working on manufacturing storefronts, for example, storefront systems, and they'll want it to cure a little bit faster. These are generally going to be about a 24-hour full cure, but it depends on the warmth and the amount of humidity. So it'll start to skin over in 10 to 30 minutes, which is very, very, very good because it allows time for us to tool it into place around your metal panel or your roofing, whatever the joint may be. And then we're able to come back and we can put our finger on that bead about 10 to 30 minutes later, depending on where you're at, maybe 10 minutes in Miami, maybe 30 minutes in Winnipeg. And then we're able to remove our finger and then the sealant did not actually come off on our finger. That's called skin time or tack-free time. And this is good because what we're actually getting is anything that's landing on it. You know, these are adhesive sealants, so they're tacky by nature until cured. So anything that lands on it during that time frame, if we're on a dusty project, for example, that dust, whatever's landing on the bead, will actually become part of the final product. So the only thing we can really do there if we don't like the aesthetics is to cut it out and reinstall or to put another bead on top of it and be able to live with a little bit larger of a bead for that application. So very, very good that, you know, we're able to skin over, but then full cure again is going to be about 24 hours. The two component systems will help expedite that. You know, there's an accelerator in there to help make that go faster. And we generally see that more in your structural systems than non-structural. And in the manufacturing, things like doors and windows. With compatibility, you're not going to get better than a neutral cure silicone, as I mentioned. You can't get really much better for UV resistance. This technology is inorganic in composition, so it doesn't break down with UV light. There is a requirement for structural curtain wall applications. This is a quick side note that structural silicone be used. Cannot use polyurethane or butyls or anything like that for or even some of your super glue type materials. It's a cyanoacrylate glue. You can glue your fingers together for sure, but it's not. It finishes very hard and it's brittle. And in fact, you know, the shear, it won't withstand the amount of shear that is required for some of these applications. So we actually don't want it to finish too hard. We want to have some movement capability, and a structural silicone, although it will finish much harder. There's a score through ASTM testing called the Shore A. There's a test with a durometer, and you'll see this on your technical data sheets. You know, how firm will the sealant finish? You know, and I have I was going to show you later, but the real beads of silicone here on the different types of colors. And when you press into it, you know, how rubbery is it? How much movement capability is it? How much can you compress it and stretch it? Neutral cure structural sealant is not going to have that. It's going to finish off more rigid, but it still allows some movement. So if you think about a structural curtain wall system, you know, if you're in downtown Chicago and, you know, you're looking at these beautiful all glass, you know, buildings, there's, you know, a structural silicone that's used to adhere many of those insulated glass units to the mullions of framing of the building. But we need to make sure that we're using a structural silicone so that it's going to withstand some of the wind and other dynamic forces, vibrations, deflection, so that it's going to last over time. As I mentioned, non-corrosive is part of its compatibility, and this is why we actually warranty the neutral cure silicone similar to what Dow does with 20 years. Hybrids are a small step below the neutral cure silicones. They are going to offer low odor, excellent adhesion on many substrates, and they're compatible with many types of construction materials and also have good UV ray resistance. So it's not excellent UV ray resistance. That's why it's not going to last as long as a neutral cure silicone. However, the biggest benefit of using a hybrid is going to be in its paintability. It's you're going to be able to paint over this. You know, we offer this in many different types of colors as well. So we just, as a side note, I was just at the IBS show in Las Vegas a couple weeks back, and we're working with siding companies like James Hardie and LP and Ceraclad, along with many others, to bring paintable sealants that are going to offer some durability over time. But they don't paint it right away. They're just matching the color that they want it to be. And if a homeowner, or if it's, you know, if it's even in commercial work, if it's a store owner, building owner wants to change color, you know, 15 years from now, 10, 15 years from now, are they going to be able to paint over that to match the new color of the building, or are they going to have to come back through and cut it out? And the status quo over many years has been that anytime we're going through a project like that, we have to cut it out and reinstall. There's a lot of labor involved, and you know, the paintability here is an excellent benefit for the hybrid. The polyurethane sealants, low to medium odor, So a little bit more odor than the others, but it does have excellent adhesion on many substrates. This is why the polyurethanes were in fact even used for exterior applications for many, many years. So we don't see it very often, if ever, anymore for exterior applications because it breaks down so quickly with the UV light. However, it is an excellent adhesion when the UV light's not affecting it. So, something to keep in mind as well, but then there can be some compatibility concerns. So I'll may be able to discuss, again, I have 4 presentations, so I get some slides mixed up, but we may have a slide in this presentation regarding the compatibility with setting blocks, a little bit more for building facade glazing, but we can see polyurethanes with certain types of setting blocks that will cause some staining. So again, I think I've driven this point home pretty heavily. This is a poor UV ray resistance for this type of sealant. Again, just a slide here to indicate that the polyurethane is organic, silicone's inorganic. And this is a great picture of what a bead of polyurethane looks like or can look like quite quickly. This was actually 3 years. This was snapped by a colleague of mine as he was on his way. He was walking into a building to deliver an architect presentation, and the building, the offices of the firm where they were in had this. And so he didn't know how old it was, but he went in and he showed them the picture during the presentation and then actually asked them. And they said it was done 3 years ago. So typically we're seeing more than that, 7, 8 years, maybe 10 if you're not getting a lot of UV light affecting it, but you can see it's just complete failure here. So a bead of neutral cure silicone is not going to be affected by the UV light. So the bead you're installing today is going to be the bead you'll have. Again, some effects of UV rays on your sealants. 8 years here, 8 years for this one, and again, this one was for the 3 years that I mentioned. So something to keep in mind, this is 15 years is still a good bead with silicone or hybrid, so it's maintaining its performance there over time. One of the things that we should consider when working with these different types of technologies is how they react to the temperature, not just the ambient temperature, but also the temperature of the substrates. So as I mentioned before, if we have drastic temperature changes with the sun coming up, especially in the winter months, I'm in Boston now, so we'll call it Boston. I get some pretty decent winters. And, let's call it 0 degrees, Fahrenheit overnight, but then you get a nice sunny day, sun is really warming up, and it feels like it's 80 degrees, but it's only 40 degrees Fahrenheit. But the panels, if it's a dark panel, will be much warmer than that. When the sun goes away, it goes over the top of the building on the other side, the temperature of that panel is going to drastically reduce, and then we're going to increase this joint size will actually increase significantly. It depends on the thermal, coefficient, the movement of the actual panel, the amount of reinforcements there, the type of aluminum. There's a lot of factors that go into it, but we're seeing a lot of movement, especially as panels get larger and larger. And so if we're getting drastic temperature movement, we need to be mindful of when we're installing the bead of seal. If we're installing it prior to the sun warming up the panel or the substrate warming up quite quickly, then what can happen is that there's an effect where the panels are actually decreasing the joint size. And if the sealant's still wet, again, think about it being a 24-hour cure period, but at least we want to have, an 1/8 of an inch or so of skin layer over there where you're starting to get some integrity of the bead to be able to prevent bubbling or pitting of the sealant, because if, we're squeezing a wet product out, it's not going to go through, it's not going to handle the compression. It's going to want to sort of squeeze out of the joint cavity. So you can see some bubbling here and there in those sort of instances. On the flip side, when we have the sun dropping and moving away from the panels, at the end of the day, and the sealant was just installed, then the joint cavity would have been wider than usual, and then now it's going to sorry, the joint cavity would have been smaller than usual because the sun was causing the panel to be quite warm. And so you have a thinner joint cavity. And then when the sun actually goes beyond and the panel starts to drastically reduce, the temperature starts to drastically reduce to air temperature, this is where the panel is going to go back to where it wants to be. So the joint size is going to actually increase. And as the joint size is increasing, if the bead was just installed, there's not enough structural integrity of the skin layer. This is, again, moisture cure is occurring from the outside inward. And that skin layer that I referenced, when you can take your finger and place on it and remove it, and there's no sealant there, that's not going to be strong enough to withstand the movement. So you can get some cracking in your bead of seal at that point in time. So something to keep in mind, especially for these types of panel applications where we see a lot more movement. Another thing to keep in mind for the cold is, I'll just reference this quickly, is that with neutral cure silicones, we can actually install that at any temperature, within reason. So it was, I think it said here below, down to -40 degrees. It's going to dramatically slow, the curing process will dramatically slow. It's called vulcanization, is that curing process I've referenced. But you can install it. But a polyurethane, for example, and some thermoplastics with more water and solvent content, they're going to change in consistency or density, during really, really cold weather. And so if what we're seeing is installers will sort of do a shortcut, they'll try to save their hands and their wrists and forearms from squeezing out the really hard, dense sealant into a joint cavity. They'll warm up these sausages or cartridges in a lamp box and heat box and a job box, and then they'll install this bead. And so it's easier to tool out. However, it's very challenging and can create a major issue for adhesion over time if we're introducing a warm sealant to a cold substrate. When this takes place, we're actually introducing a layer of condensation on the backside of the bead. And with a moisture cure, we don't want to prematurely introduce moisture to the backside. We want to cure from the outside inward to allow it to go through its chemical bonding process. And so this is one of the reasons why we will see DLAM. It's similar to if there's, if it's really, really heavy fog or there's dew, morning dew on the substrates, or it's just rained, frost, for example, we want to make sure that these joint cavities are clean and dry. With a neutral cure silicone, you don't have to. The consistency of the product doesn't change. It's inorganic with the temperature, so you can gun it out just the same at 0 degrees Fahrenheit is what it's going to be at 70 degrees Fahrenheit, essentially. So there's no need to warm it up. And we're actually actively working with the installers across North America, especially in the colder states and provinces, to ensure that the status quo that installers have been doing for 10, 15, 20 years, and when they were using polyurethanes, that they've made this pivot, this adjustment to saying, wait, I was doing that before, now I'm using this new seal, but now I don't need to warm it up, and I shouldn't warm it up. So if people are wanting to warm up a sealant like that, a thermoplastic or a polyurethane, it's okay to do that as long as you're warming up the substrates. Okay? It's less about the air temperature, more about the substrate temperature. So if you're tarping off and warming up substrates, there shouldn't be any issues with the condensation. On the hot side, this is really important for polyurethanes and for thermoplastics. Because it changes, with the cold weather, it gets much more dense, but with the warm weather, it gets much more runny, liquidy. You can feel it in the cartridge or sausage, especially sausages, that it's actually becoming a lot more runny. And so for your vertical applications or overhead applications, it's not as ideal. You're going to get a lot of sag, and it can become quite difficult to tool into place. One of the things I mentioned earlier was this chalking phenomenon that takes place. So this is a pretty extreme example of, you see all this white chalking. This was not the color of the bead of seal that went into this joint cavity, but because it was tooled into place, it caused this chemical reaction that causes chalking. Most hybrid sealants, in fact, I'm not aware of any others besides ours that you can tool in. Our 1940 hybrid series, the reason why we're having a lot of success with installers across North America for paneling type systems that would require some paintability, is because ours is toolable, which is going to help the durability over time. Durability, if we just break it down into a simple equation, is going to equate to adhesion to the substrates, good compatibility, and movement capability as well. So when we have better adhesion because we're maximizing the amount of surface area that we're applying the sealant to, so we're pressing into the joint cavity, we're making sure to maximize the edges of these panels, then we're able to then realize the full benefits of the elastomeric properties, the movement capability. If the product's laid in here and they're not adhering very well on the backside of the bead to the edge of the paneling, then why does it matter if you have great elastomeric properties? Because it doesn't have anything to adhere to, right? We need to maximize adhesion in order to realize the full benefits of the movement capability. Fading can take place as well. So we have some pictures here clearly for different types of siding, but it's relevant to all different types of substrates, including metal paneling, metal roofing. So we want to make sure that we're using sealants that aren't going to fade over time. Polyurethanes, again, we're using the market because of it. They're an excellent adhesive, and it was really sort of just understood that in about 8 to 10 years we're going to have to cut it out and reinstall. But with the neutral cure silicones and hybrids now in the market, you're having excellent adhesion across the board for many different common substrates, and then thermoplastics you'll see here are even less than that of a polyurethane. So when you're in thermoplastics, you're class 25 sort of product, and then class 35 for a polyurethane, and then class 50 or class 100/50 for a neutral pure silicone, and class 50 for a hybrid. Speaking of the class system, let's dive into a little bit of the ASTM standards for both movement and weather sealing capability. So this is C920, which is the standard specification for elastomeric joint sealants. And what you're seeing here, we reference single or multi-component. Most of what you'll see used on projects is going to be the single component. The SAG that I referenced earlier, especially in warm conditions, there are many products that are in the market where they're very, very dense, very heavy, and they actually do not come with a non-SAG designation, so they're not ideal for your vertical when you're installing vertically on the side of a home or a business. And then you have your various different types of substrates here, the types of components that are in the system. So in the center here, this class system. This is through ASTM C719. It's called the Hockman cycle. It's a series of movements of ups and downs where we're really stretching the sealant and determining its elongation, its percentage of elongation, and then we're compressing it back to determine how much force will it take and not affect the structural integrity of the bead itself. Most sealants, you'll see, I just referenced thermoplastics at 25%. Some polyurethanes are in the 35% category, and then 50% and greater for neutral pure silicones. 50% is about the best we can do on the hybrids. But when you see just a class 50, it means it's 50% for both, 50% for elongation, 50% for compression. When we get to 100%, this is for the elongation. Again, I referenced the half-inch bead that can go up to 1 inch and then come back to its half-inch state. But it can also be compressed down to 1/4 of an inch and still maintain its structural integrity over time. So that's a little bit of the nomenclature behind the scenes on ASTM testing. D412 is going to test that tensile strength at different percentages of elongation. So this is going to offer the ultimate tensile strength. So this is going to be a document or a measurement, a result that you'll see on the actual technical data sheets as well. And then we have the ASTM C719 Hockman cycle that I referenced. We have in bold here the class 50s and the class 100/50s. So if you're looking to maximize durability over time because of its adhesion properties, because of its compatibility across many different types of substrates, and it won't break down to UV light, and also because of its movement capability, this is where we would recommend the class 50. Most of what we see used for perimeter weather seal in the market for also different types of applications, whether it's the masons, the glaziers, metal facade installers, the roofing installers. We have mostly seen class 50 used in the market. The hardness that I referenced earlier is through the like an ASTM D2240. So we're using a durometer to drive a pin into the seal to be able to say, hey, this is finishing off much more rigid, much harder than that of a different sealant. So if you're looking for something to be more of an adhesive and not have as much movement capability, then the durometer can give you, that score to ensure that you're going to finish off with a little bit of a harder product, but still offer, as I said, some movement capability. Those that finish off more soft, like the low modulus product that I referenced, is going to be primarily intended for maximizing elongation. You still get excellent adhesive properties, but the actual adhesion, the pull-out strength of the sealant itself would be stronger with that of a structural. I referenced staining earlier, and we do see this, as mentioned, with polyurethanes over time with sunlight, and it's sort of bleeding into porous substrates. So we have to do a lot of testing in the laboratories to try to mimic field conditions. And so you're looking at different types of temperatures, a different time frame of being in the laboratory here. They're in UV testing chambers, ovens, and this, when we're going through this for concrete, brick, limestone, granite, marble, these types of stone and porous materials, we can determine if there's some leaching that takes place, some bleeding that takes place into the porous substrates. As you can see with the neutral pure silicone, you don't have anything to worry about here. It's more with the other types of, with the polyurethanes or thermoplastics. The ASTM C1087 is for essentially ensuring that we're going to have good adhesion to the substrates. So whereas before we've looked at structural integrity of the unit, the staining, if there's going to be some sort of staining potential with the substrates, but now we're looking at the actual adhesion. And so what you'll have here is cohesive failure is where the sealant itself is breaking. And in the realm of this sort of testing, the term failure doesn't necessarily mean that it's not working. When we have cohesive failure, this is actually a good thing. The sealant will at some point in time break upon itself. In fact, the pull test that we do for in the field is where we're cutting a bead of sealant, we're pulling it to break. We just want to make sure that it's not going to pull out of the joint cavity any further than the area that we cut. So it will break, and it'll start to stretch, get much thinner, and then all of a sudden it'll snap and break. This is called cohesive failure, and this is what we're looking for. So adhesive failure is where it does not break, and so it's actually pulling away from the substrate that you would intended for it to adhere to. So there's different types of tests that can be done with ovens, with freezers, different UV light conditions, different moisture conditions, doing all those testing in the laboratory as well. I'll pivot to talk a little bit about the sealant for metal roofing applications. So this is where we have a lot of customers in North America that are using our 4580. It's offered in over 400 colors, as I mentioned. So you can match any of the metal panels that you're using for your roofing applications. It's going to offer excellent compatibility, good adhesion, and that UV, it's the best in terms of UV resistance. So great product for roofers to use for sure. For the architectural metal paneling, we're seeing a similar type of product that's used. So the fun thing is we're seeing many more buildings like this where there's just a lot of color involved. It's not necessarily for everybody. I think it's really cool, just because I work for a manufacturer of sealants with over 400 colors. But it's just really cool to see architects have a lot of fun with projects these days. So the two-component chemical cure that I referenced earlier, this is more for your adhesives for the architectural metal paneling system. So this is when they're creating the panels themselves. They can use a two-component type of product that's going to, like a methacrylate type product, that's going to offer very, very fast adhesion and cure. So it can be 5 minutes, 10 minutes, 15 minutes, depending on the formulation. And this is used more in a controlled factory type of environment, but it rapidly accelerates the adhesion and curing process. The one component that I mentioned earlier will take much more time. But we do have some panel manufacturers who are using these type of product on the back side, and they'll allow for it to go through, a 24-hour curing process. And, because it's on a production table, and it's going to sit there overnight. And so they're able to use that because it's a much lower cost point than that of a 2-component. We can take a look at some of the, diagrams here. This is cross-sectional view of your ACM panels. So you have your composite panel, and then the mechanical fastening system here. And this is where some of the adhesives are being applied, in addition to any mechanical fasteners. So mechanical fastening is not a requirement for many of these panels. If we think about it, the insulated glass units that are being affixed to a building, 50 stories up in Chicago, if it's a 4-sided structural curtain wall system, there's no mechanical retention of those units to the building. It's actually just a 1/4 inch to a 1/2 inch bead of structural silicone. So it's an excellent adhesive. It's going to allow for a little bit of movement and deflection, vibration, wind. All these sort of things can wreak havoc on even mechanical fastenings, where you start to loosen up over time. This is designed to take that, offer just a little bit of movement, and it always wants to go back to where it initially was. When we're doing the building envelope, there's a lot of different types of sealant applications. Now, there are some bold looks where we're installing a bead of sealant to really make it pop. And then there are those where we want it to be sleek and sort of just blend in. You don't see the joints in the systems, and they would just perfectly match the sealant color to the panel itself. For your perimeter weather seal, there's a lot of different types of applications, a lot of different types of substrates that are coming up to, for example, doors and windows. And so here's where we would want to use a soft open cell bicellular backer rod, where it's got a thin membrane around it to help prevent water from permeating through. So one of the benefits of a hard closed cell system for backer rod is that it's going to prevent water from actually permeating through that backer rod. However, if one of the major drawbacks of it is, and why we wouldn't recommend it for these sort of applications, is that if you puncture it during this application, we've got to install this backer rod to a depth of anywhere between 1/4 to a 1/2 inch. So the installer is using tools to put this into place. And if those tools are puncturing, or if it's up against a substrate that's abrasive, it can actually cause some outgassing, which is cause some bubbling or pitting of the sealant. It can cause, it can result in less adhesion to the edge of your windows or doors or siding and your metal panels. So for these applications, we recommend soft open cell bicellular rod. And there are some applications we bring both types to market. So we bring hard rod to market as well. But roofers sometimes, when they're laying down panels, if they want a little bit of a air barrier there, just not to lay the panel right down flush, then they'll use the hard backer rod to lay down. But they don't have to worry about puncturing the rod. So that's okay in those circumstances. The 4580 that I referenced earlier is a class 50. It's very, very common. This is the one that has over 400 colors. It's primarily used for non-structural applications. However, it does have good enough adhesion to achieve a structural rating in the United States for 2-sided structural curtain wall applications. So, for example, if you have an all-glass building in terms of the facade, and they're installing the units, but they're fixing at the floor levels, they're having mechanical fastenings, but on the verticals of those insulated glass units, they're actually adhering them to the mullions with a structural silicone. So I share that only to refer to how much adhesion power that this product has. The low modulus, the biggest benefit of a low modulus is that it's going to offer 100% movement capability if installed correctly. And you have the excellent adhesion to the substrates. So it's a non-sag. It's a little bit thinner of a product. So if you're bringing your paneling system up against something that's porous, let's call it brick or stone, concrete, we can actually achieve not only the chemical bond that takes place, but also a little bit of mechanical bond as well, because if it's porous and it's a little bit of a thinner product, it can kind of get into some of the nooks and crannies of the concrete, for example, and create, once cured, what's called a micro keying effect, which makes it harder to pull out. You'll see this more in expansion joints for the masons, but this also comes in the same number of colors, over 400 colors, to match all different types of substrates. The color chart that I was showing you earlier, if everybody saw it, I mean, we can send these out. We send these out to architectural firms all the time. A lot of install firms will take this out as well to show their clients, their homeowners, to say, hey, are there any colors in the standard chart? There's 77 standard colors. There's actually 5 metallic colors here at the bottom as well, 5 of the 13 that we offer. So these are real beads of silicone, as you can see, and lots of different types of colors, in the standard range, where our customers can purchase just one cartridge if they like of any of these types of colors. The balance of the colors I mentioned, over 400, are available for what's called, it's on demand. So it's not a standard color. We can do a small batch production of 100 cartridges. So it's, I think it's best in class in the industry. Or it would be, 108 sausages. We have to do sausages. And then, joint design that I referenced earlier. So, the angle joint is not going to necessarily be considered a movement joint, but we still want to use a back rod or an anti-adhesive tape, something similar to a polyethylene or Teflon type material for when we're tooling these into place. And I'll just quickly go through some of the joint designs here. So we have quite a few joint designs. This is an expansion joint. We'll want to make a 2-to-1 width to depth ratio. Use that soft open cell backer rod to prevent anchoring the product to something else. We just want to maximize movement between these two substrates, so we don't want to anchor. So the moisture cure sealants will not adhere to a polyethylene soft backer rod. So that's the ideal. That's why that's used. And you'll see time and time again here the same thing, 1/4 inch to 1/2 inch max depth. And you'll also see this concavity here. Again, the thermoplastics, we need to make it convex, but we want to actually press it in the center here to push it toward the substrates, the edges here, and that we're maximizing movement capability. If we have to repair a joint, we can actually go in, or a joint seal, but we can't remove the defective sealant for some reason, or can't fully remove it, then we can come in with an anti-adhesive tape, but we have to be able to live with a little bit larger of a bead of sealant to make sure we're getting that 1/4 inch minimum bite onto the balance there. So we will sort of wrap up here with some of the application procedures. This is for mechanically removing the old sealant. We do need to cut away if it's in a brick or a porous type substrate. We want to cut away, grind away as much as we can. We want to clean it. We want to insert the soft backer rod and apply the sealant, and then we can use a solution of 95% water, 5% clear dish soap for tooling it into place. There's tooling sticks that are similar to like a shim. They're tapered. They come in different widths. A lot of installers will throw it into a thermos with 95% water, 5% clear dish soap, and it helps to slick the bead really nicely. The importance of backing tooling, you see here, this concavity is what we want. We want to press it into place. This is the reason why. If we're not pressing it into place, we have to lay a bead of hybrid in here that's not toolable. It'll stay right on the cartridge. For many hybrids, not toolable. Then we can't maximize the adhesion on the backside. So this is what we want to look for. It's a much better aesthetic, and we're maximizing adhesion on the sides. Tooling kits as referenced. Angle shaping tools. Backer rod, different sizes, up to 4 inch actually for backer rod. It's soft, so it's a compression fit, so you need to go larger than the joint size. And then here's a quick video on how to slick that type of bead. Makes for a really nice finish, especially when you have a good match. Wrapping up here with on-site testing, there's a pull test that we can do, and this is recommended after 7 days, but we would actually, it can be done after 7 days. We recommend between 21 and 28 days for full cure. So we're cutting away here, and then we're actually pulling the bead. We're sort of maximizing the elongation here. We're gonna pull, and we're pulling all the way to break, all the way to the point where this is going to break off, but we don't want it to pull out of the joint cavity. If we're pulling away and it starts to rip out of the joint cavity, then we know there's been some dust, some debris. It may not be the right type of sealant at all. Maybe there's some oils on your metals or on the framing, from fabrication. Maybe there's frost or dew, or it rained shortly before the project and they didn't dry it off. So these are some of the reasons for being able to pull this right out of the joint cavity. So we do recommend, if you can do a mock-up area, if you're using a new type of sealant technology, that you can make an adjustment here to the first time you're doing it. You can test this method out and make sure you're getting excellent adhesion. Compatibility, I'll just mention this because with weather membranes, a lot of them are polyethylene or polypropylene, and so moisture cure sealant adhesive sealants rather, do not stick well to polyethylene or polypropylene type materials unless it's been through what's called a corona treatment. This is a heat treatment process that changes the surface tension of the material to allow for an adhesive to actually do its job. And this is the type of heat process that's in there. Generally, if it's got branding on it, you're going to be in pretty good shape that it's been through the heat treatment process. And this is one of the mentioned things that I showed earlier, something for the polyurethane with heat in terms of staining, but we can actually see the solvent-based materials. So some of the thermoplastic solvent-based are actually going to just can create havoc on a project when it gets into extreme heat. When working with membranes and having a very bad chemical reaction there. The solvent-based sealant over insulating foam, this is where you can get some bubbling as well, something else to keep in mind. And then, of course, the available packaging is most contractors are using the sausages. However, for a lot of residential projects, we're seeing the use of cartridges still. So 10 ounces or 304 milliliters. And then we've got like a 600 milliliter sausage, which would be closer to 20 ounces. These are more for our industrial type customers. We actually bring some product in totes, which would be closer to 250 gallons. The environmental footprint is super important to consider. This is something that we're working on quite closely as part of our efforts to reduce our environmental footprint. So these are our 6 axes of processes that are being analyzed. And we're undergoing ISO 14001 certification. So lots of research is being done in our laboratories. We really are pushing the sausage format because it's much more friendly to the earth. It's not as much plastic in the landfills, but it's also providing a lot more productivity gain and cost savings. Well, I should say this, cost savings through productivity gain and also less product waste. Both in the packaging itself, because we can't possibly get all the sealant out of a plastic cartridge, but also in that we're able to use the same nozzle tip essentially the whole day or for the whole application, versus every time we're changing a cartridge out, we're using a new nozzle and we're wasting 5% of the product every time there as well. The productivity gain is what most contractors really love. They put one in, they can rock and roll, and it's easier for them to squeeze the guns as well. Lastly here, the important links for some good reference material for you all is the compatibility tool. So you can take a look at the different types of paneling systems that you're working with, and to ensure there's good compatibility with the type of adhesive sealant that you're using. The color matching tool for especially in metal trades is a lot of fun to use. You can use this, find colors by manufacturer as a drop down. And then you can select the manufacturer, then you select the different colors, and it'll kick out exactly the type of color that you would need. It's already been formulated. If we have not formulated the color already, we can turn around in about 2 weeks. We just need a sample of the substrate in our laboratory to do that. And then again, very low minimum order quantity to do a custom color. And then we won't have 400 colors, we'll have 401 colors, and so on and so forth. Sealant calculators, the last piece here is you can just, if you're doing takeoff for estimation purposes, you can enter the joint dimensions and then the coverage in linear feet for your project, and it'll kick out right away the number of cartridges or sausages that you would need for the project. So terrific, quick tool. A lot of fun for our customers to keep that at the ready. So that's it for today. Thanks for those of you who were able to stick on a little bit late. A lot of content in this presentation. And I'd like to open up for Q&A if anybody wants to stay on. For those who have to run, thanks again for sticking around for the presentation. And if you dropped a question into the chat, I will work with Keelan to review those questions, and we will be getting back to you right away. So without further ado, I'm going to pass it back over to Kaylin. And if, again, there's anybody wants to stick around, please feel free to do so. I'll be glad to connect with you now or later. Thanks so much for attending this presentation. Take care.
Thank you for speaking, Dan. We so appreciate having you here today and having you for the times that we've had you speak. This is a fantastic presentation. It's one that's highly requested. We do not have any questions currently, so I'm going to start closing out the session. If any questions come through, I'll speak for them. So thank you everyone who was here today live with us, and special thank you to everyone who is watching us in the future on the recorded version of this webinar. We so appreciate your time, and we hope to see you at a future MetalCon Live and a MetalCon Online. Again, Dan, thank you so much for being with us today and for speaking. Everyone who is joining us today, we hope to see you at MetalCon in person, and we hope to see you at a future MetalCon Live. Have a great rest of your day, everybody.
Thanks. See you.